Assalamu alaikum, my dear students. Today I will discuss homogeneous function. At first we have to know what is homogeneous function, and next I will solve some problems about homogeneous function. Okay, let us see what is homogeneous function. A function f of x is said to be homogeneous of degree n in the variable of x and y if it can be expressed in the form of x power n phi of y by x or y power n phi of x by y. We have to see carefully if here x it will be here y, and if here y it will be x. We have to look this carefully. Euler's formula for homogeneous function related to partial differentiation. So we have to know Euler's formula for homogeneous function to solve these types of problems. Okay, let us see the Euler's formula for homogeneous function. If x, y be a homogeneous function of x, y of degree n, here n is equal to degree, then x del f del x, y del f del y, this is equal to nf. We have to know this equation for solving these types of problems. Similarly, if there are three variables x, y, z is the function of f, and if it is homogeneous function, we can be expressed by using Euler's formula, x del f del x plus y del f del y, z del f del s del z, this is equal to nf. Now I will solve some problem related to homogeneous differential function using Euler's formula. Problem, I have given two problems. If u is equal to tan inverse x cube plus y cube divided by x minus y, prove that number 1 and number 2. At first we have to prove number 1 and then we have to prove number 2 using number 1. Okay, at first we have to check either homogeneous or not. Okay, u is equal to tan inverse x cube plus y cube over x minus y. So we can write from this equation tan u is equal to x cube plus y cube x minus y. We have to make this equation in the form of x power n phi of y by x or y power n phi of x by y. Okay, taking common y cube, we get x cube plus y cube plus 1, and from here taking y, we get x by y minus 1. So we can write tan u is equal to y square x cube y cube, that means x by y whole cube plus 1 divided by x by y minus 1. So y power n and x divided by y. So this is the form of y power n phi of x by y. So this is homogeneous function. This is the homogeneous function. So we can write, so tan u is a homogeneous function of x and y degree in 2. So according to Euler formula, we can write x del f del x y del f del y, this is equal to nf. So here x del x, f, that means function of xy. Here tan u is function of x and y of degree 2. So we can write tan u. Similarly here tan u, 2 tan u, 2 tan u. So differentiating, we can write, if we differentiate tan, it can be written sec square. So sec square u and del u del x. Similarly plus y sec square u del u del y, this is equal to 2 tan of u. From here taking common sec square u, x del u del x, y del u del y, this is equal to 2 tan of u. So x del u del x, y del u del y, 2 tan u divided by sec square u. Or del u del x, del u del y, this is equal to 2 sin u cos u, and sec, this is equal to 1 by cos square, that means cos square u divided by 1. So x del u del x, y del u del y, this is equal to 2 sin u cos u, and we know that 2 sin theta into cos theta, this is equal to sin 2 theta. So we can write x del u del x, del u del y, this is equal to sin 2u. Proved. Okay, number 1 proved. Now we have to prove number 2 using this, and we have to look number 2 left side, and the left side of number 2 del u del x to del u to del y to. So we have to differentiate this equation first with respect to x and next with respect to y. So at first partially differentiating this function with respect to x. Okay, differentiating partially with respect to x, taking this equation 1, we get, okay, that means del x, x del u del x plus y del u del y del x sin 2u. Okay, here we can write del x, x del u del x, del x, y del u del y, and differentiating this we get 2 cos 2u del u del x. Okay, here this is the formula of u v. So u del x v, v del x u, that means x. Similarly here applying uv method, we get y del x del u del y plus del u del y del x y, and here 2 cos 2u del u del x. The viewers who don't know partial differentiation, check my description box and click on the link to watch the video about partial differentiation. Okay, x del 2 y del x2 plus del u x is equal to 1. So y del 2 y del x del y and del u del y and del u del x, del u del y del x, this is equal to 2 cos 2u del u del x. Since we are differentiating with respect to x, partially differentiating with respect to x, so y is equal to constant. So here del u del x this is equal to 0. Del u del y del x del y del x del y del x this is equal to 0. So this term will be 0. So neglecting this term we get now the left side of the equation which is given to prove x square. So we have to multiply this equation by x. If we multiply this equation by x, we'll get here x square. So multiplying both sides by x we get. Okay, if we multiply both sides by x, this equation will be in the form of x square del 2u del x2 plus x del u del x plus xy del 2u del x del y, this is equal to 2x cos 2u del u del x. Now we have to differentiate equation number 1 partially with respect to y. So partially differentiating equation 1 by with respect to y. So del y x del u del x y del u del y del y sin 2u. We have already proved equation number 1, and at first we have to differentiate partially with respect to x, and next we have to differentiate partially with respect to y. So if we partially differentiate with respect to x, this is equal to u and this is equal to v. So we can write x del 2u del x del y plus del u del x, because we are partially differentiating with respect to y, and here x is equal to constant. So if we differentiate constant, these terms will be 0. So x, so neglecting these terms del x del y, this is equal to 0. So neglecting this term. Okay. Similarly, if we differentiate this using UV method, we can write y del 2y del y2 plus del u del y and del y, this is equal to 1, so only del u del y. So 2 cos 2u del u del y. So we have to multiply this equation by y. Okay, multiplying by y. So we can write xy del u del 2 del u del x del y square del 2y del y2 plus y del u del y 2y cos 2u del u del y. This is the equation number 2 and this is the equation number 3. So we have to add this equation if we want to prove number 2. So adding 1 and 2 we get, adding 1 and 2 we have to add adding 2 and 3 we have to add 2, and equation number 3 we can write plus xy. We have to write adding 2 and equation number 3 xy del 2 u del x del y plus y square del 2 u del y square plus y del u del x. This is equal to 2x cos 2u del x del y, del x del u del x and 2y cos 2u del u del y. Okay, so in the side x square del u del 2u del x2 plus xy two terms, so 2xy. Similarly plus y square del 2u del y2, and here 2x cos 2u del u del x and 2y cos 2u del u del y, and this side, in this side x del u del x. So taking common 2 cos 2u. If we take common 2 cos 2u, we can write x del u del x plus y del u del y, and if we take right side x del u del x, y del u del y, we can write minus x del u del x plus y del u del y. So x square del 2u del x2 2xy del 2u del x del y y del 2u del y2. Now taking common, we can write 2 cos 2u minus 1 x del u del x plus y del u del y. Okay, left side is complete or perfect for proof, but we have to prove right side. So according to the proof, we can write 2 cos 2u minus 1 x del u del x plus y del u del y. This is equal to, we know, sin 2u. Okay, sin 2u from number 1. Now we have to make this in the form of sines. Sine. Okay, cos 2 theta, this is equal to 1 minus 2 sine square theta. That means sine square u minus 1 sine 2u. Okay, so we can write 2 minus 4 sine square u minus 1 sine 2u. So we can write 1 minus 4 sine square u sine 2u. Proved. Okay, thanks for watching this video, and next class I will come back with new topics inshallah. And the people or viewers who are the new viewers of my channel, please subscribe my channel and click on bell icon to watch new videos. And please check my description box to watch different types of video related to this video class, and check my playlist to watch different types of videos or different subjects. Okay, Allah Hafiz.